Welcome to Unit 4, Lesson 1, Number Puzzles. Today we're going to start start into more of what we consider algebra by solving equations. And in this case, we're going to start with some number puzzles. Before we get into that, let's talk about notice and wonder. We have a number line here. What do you notice and what do you wonder? Some possible things that you can say is I see 3 colored arrows above the number line and 1 black one down below. I wonder why that black one is down below the number line instead of above the others. I see 3 arrows pointing to the right, 1 pointing to the left. I see the blue one is really short, the black one is really long. There's a lot of different things that we can look at with this. So it's really just meant to get you to analyze what it is. I can say that, oh, the blue one is 4 units long. Be thinking about it, come up with something on your own. When we talk about our lesson, telling temperatures, we need to be able to solve each of the following equations or each of the puzzles, and we need to show our thinking. So we're going to organize it so it can be followed by other people. In this case, the temperature was very cold. I think that's important to know. Then the temperature doubled, and then the temperature dropped by 10 degrees, and then the temperature increased by 40 degrees. And the temperature is now 60 degrees. So what is the starting temperature? Well, that's a really good question. And that's where we meet our first piece of information here is within the question, what was the starting temperature? When we talk about this, we're going to start understanding what a variable is. A variable is an unknown or changing value. We already have talked about the changing value by understanding that we have X and Y coordinates and they change as a line increases or decreases or progresses across a plane. An unknown value means that it has either one value for that value, or it could, like we saw in the coordinate planes, change, or it might not have a value at all. In this case, we're looking for an unknown value of a temperature and where we started with that temperature. So the way we're going to do this, so we're actually going to start out by identifying our variable. In this case, let's go ahead and say, let T be the starting temperature. We want to identify that variable so that we know exactly what T means when we write our equation for this. We need to be able to show our thinking. So what we know with this is that the temperature was very cold. And so if the temperature was very cold, we know that it was some temperature we don't know of. We know that it was doubled, so we can multiply that by 2. Dropping 10 degrees is minus 10 degrees. And then increasing 40 degrees would be plus 40 degrees for a temperature of 16 degrees. Now, what was the starting temperature? In order to figure this out, all we have to do is work backwards. In order to get T all by itself, we need to consider what we have to do to undo what was done from the 16 degrees. So I could just simply work backwards with this to come up with something a little different. So if the starting temperature, if we're now at 16 degrees, rather than adding 40 degrees, I need to work backwards, take away that 40 degrees. And then the backwards version of, or the opposite version of dropping 10 degrees would be plus 10 degrees. But then I have to think about this. If I doubled it, then that means that I doubled my temperature. I would have to take all of this and multiply it by 1/2 to give me the beginning temperature. 16 minus 40 is a minus 24. Plus 10 is a minus 14, times 1/2 is a minus 7. So our starting temperature would have been a negative 7 degrees. That would be our answer for the first one. Let's go and look at the second one. Whoops, not that one, this one. If Lynn ran twice as far as Diego, and Diego ran 300 meters farther than Jada, and Jada ran 1/3 the distance that Noah ran, and Noah ran 1,200 meters, how far did Lynn run? Well, we might be saying, well, what are we supposed to figure out? Well, if we're supposed to figure out how far did Lynn run, then that's going to be our variable. So we can say let x be Lynn's distance. And now we can work with this. Anywhere we see how far Lynn ran, we can make that into it. Oh, whoops, I didn't even put anything in there. Let x be Lynn's distance. I don't like that. We need to be able to see it. So when we talk about Lynn running twice as far as Diego, we can see 2 times further than Diego. But I'm not going to put 2x because we know how far Diego ran. If I put 2x, I'm saying twice as far as Lynn, and I don't want that. Diego ran 300 meters farther than Jada. Jada ran half the distance that Noah ran. Noah ran 1,200 meters. How far did Lynn run? Wow, this actually kind of seems like I need to look at a couple of other pieces with this. When we talk about these distances, we need to be able to talk about a little bit more than that. I think we need to probably talk about groupings. We need to talk about Lynn ran 300 meters farther than Jada. Jada ran a third the distance of Noah. And Noah ran 1,200 meters. So maybe it would make sense to start with Noah. If we're talking about Noah, we're talking about his 1,200 meters. So we'll start with Noah's distance. What if we talk about Jada's distance next? Well, Jada's distance was 1/3 of Noah's distance. Okay. And Diego ran 300 meters farther than Jada, so 1/3 of 1,200. This is Jada's distance, but Diego ran 300 meters farther than that. By getting to each of these different people, we still don't know how far Lynn ran, but we do know exactly how far each of these people ran. Noah ran 1,200 meters. Jada ran 1/3 that distance, meaning she only ran 400 meters. And we know Diego ran 300 meters farther than Jada. So right now, Noah has actually run farther than anybody else. This one is 400. Diego's total distance is 700. And we know that Lynn ran twice as far as Diego. So what we might actually have to recognize from this is how far did Lynn run? Well, we know that this is twice as far as Diego. So we know Lynn ran 1,400 meters. Okay. When we're talking about her distance, Lynn's distance, we'll actually come back into this and talk about the variable as far as how it's going to work. But sometimes just working through the equation, setting up the things that we absolutely know makes the big difference. What this would equal would have to be x. Well, excuse me, this one down here would have to be equal to x. All of this would have to be doubled in order to make sense for this equation. How far did Lynn run? We know Lynn ran twice as far as Diego. Next one. It's your turn to make a puzzle. For this one, we're going to write another number puzzle with at least 3 steps. On a different piece of paper, write a solution to your puzzle, trade puzzles with your partner. I really wish we could do this one because it's kind of fun, because your idea would be to write a puzzle and have somebody else check it out. Give me a little bonus, write me one, email it to me, and I'll share it with everybody else, and we'll see how it comes out. I'd love to see how many of them we can get for this section right here. We'll make this something into a little bit more of a group project, but I need your input on it to be able to make it happen, so please send me one. So are you ready for more? Let's think about this one. Here's a number puzzle that uses math. Some might call it a magic trick. And let's think about your number. Think of a number and double that number. I'm going to go ahead and think of the number 3. I'm going to double that number to make it 6. I'm going to take 6 plus 9, which is 15. 15 minus 3 is equal to 12. 12 divided by 2 equals 6. And then subtract the number that you started with. 6 minus 3 equals 3. Wow, crazy, it worked. Okay, let's try another one. Let's go ahead and do 4. Double the number is 8. Add 9, 17. Subtract 3, 14. Divide by 2, 7. Minus 4 equals 3. Crazy, it's worked twice. I challenge you to try this one out several times, but the bigger thing that we need to come up with is, why does this always work? Can you think of a number puzzle that uses math like this one that will always result in 5? I would tell you with this one right here, to get something that always results into 5, all you have to do is modify this thinking just a little bit. See if you can figure it out. This is kind of a tricky one. It's kind of a fun one, but it will start to give you an idea about these little quote unquote number tricks or magic tricks with numbers and with math. So give it a little thought. That's it for our lesson. We're on to our lesson summary. Here's an example of a puzzle problem. Twice a number plus 4 is 18. What's the number? There's a lot of different ways to represent and solve the problems. We can reason through it is one way to do it, where we take twice a number plus 4 is 18. So we think about twice a number. We undo that. We start out with the 18, the end in mind. And instead of adding 4, we just subtract 4 and we get 14. And then we undo the twice a number by dividing by 2. So we find out that the number is actually 7. We could draw a diagram. And in that diagram, what we think about is our number. We would, in this case, say let x be the number. And I saw that it says twice a number, so I have 2 of those numbers. Plus 4 is 18. So as a model, it looks like this. X, X, and 4 is 18. If I think about those 2 numbers as just X and X, I know that I have to have something that's 4 less than 18. And so I would remove this 4, which would give me 14. And I know that the 2 numbers together are the exact same number, so I could just divide that by 2 and I get 14. Or we can write it out as an equation like this, where I see that 2x plus 4 is equal to 18. We know this is 2 times x, which is super important to remember. And then I would remove the 4 from both expressions to eliminate from this expression and to simplify this expression. So we have 2 times a number is 14. And then I need to undo the multiplication by dividing by 2 from each expression. And I find out that the number was actually 7. So reasoning and diagrams help us to see what's going on and why the answer is what it is. But as number puzzles and story problems get more complex, the methods are probably going to get a little bit harder. These ones about drawing it and reasoning, those are going to get a little bit more complex and a little bit harder to do. So we're going to see other types of diagrams as we go through this unit that are going to help us understand the problems and the strategies. But we're also going to see the power of writing and solving equations to answer more complex and increasingly complex problems. So there it is. Let me know if you have any questions. Thanks for hanging in today. Have a great day.